So now it's time for regression, but I wanted to show like a real example of some code training a little classification model so that you can see what these values look like. So I'll change what I'm sharing to show a little notebook with some code. Okay, so for any non-coders here, I'll try to make this as like easy to see as possible. But in here we're just importing the Scikit-learn library, which is by far the most used library in Python to make traditional machine learning models, especially classification and regression models. So I'm just going to import the things from Scikit-learn that we're going to use. And then we're going to run a Scikit-learn function called make classification that is going to generate a synthetic dataset. So I'm going to make a dataset, and we're going to say that it has 1,000 records of credit card transactions. And it has 20 different features, which are just the columns that describe each transaction. So 20 different columns like location, like vendor type, like credit card transaction amount, etc. And that there are two classes, which is fraud or not fraud. And you can ignore this. This is just to fix the randomness so that we can get consistent results. Then this is an example of a really easy data preparation step for train test split. We are going to use X to denote the 20 variables and all of their columns that we're going to use to describe each transaction, and Y to have just a column of the labels that we're going to use for predictions, so fraud or not fraud. And when we use Scikit-learn train test split and give it the explanatory variables as well as the prediction variable, we just need to specify what percentage is the data cutoff for what is the train split and what is the test split that we saw before. In this case, we're using 30% leaving outside for testing. So 30% of these 1,000 records will not be used in training. They will just be used for testing purposes, for evaluation. And then the train test split takes the two variables with all the data and separates them into the X, so explanatory variables for training, and the ones for testing. So this is 70% of the data, this X train. And this Y train is the label for that accompanies the X train. So here we have 70% of the rows for all the 20 columns. And here we have whether they were fraudulent or not, truly. And this is just the same thing, but 30% of the data set that we're leaving outside for testing. Then we choose a model. In this case, we're just choosing one model called logistic regression using all its default parameters. But training models is literally as simple as importing from Scikit-learn which model you want to use. Like here, for example, logistic regression, even though it has regression in the name, is actually a classification model. And we could be importing 10 other types of models here, which are all for classification. And it's super straightforward to train them and to make predictions with them, because all you have to do is to call them here, store them into a model variable, and then call this fit function with the training data. And that's all. This trains the model, and with this, the model is ready to make predictions, which we can then evaluate. Oops, I didn't run all the cell before. Okay, so now the model is fed to the training data. And now, if we use model.predict using the X test, which are the 20 columns with descriptors, we're going to get Y prediction, which is if this is 300 records that were not used for training, this is going to make 300 predictions. So for each of those transactions, it's going to tell us what it thinks the transaction was, either a fraud or not a fraud. And finally, once we have the predictions, we can do evaluation, which is we just use accuracy score, precision score, and recall score, comparing the model results, which is white prediction, compared with the actual labels that we left out for the specific purpose of testing. And we just compare the real data against the model predicted data. And we get the accuracy, the precision, and the recall. And we can even get the confusion matrix, which gives all of that information, just passing in the real data we left outside of training and the model predictions. And then we can print the values that we stored in all of these. And we can see that for this test example, the model got 128 true positives. So out of the 300 predictions that it made, it was right about them being fraudulent in 128 of the 300 cases. And true negatives, it was right about the transactions being normal, not fraudulent, for 127 of the 300 cases. And finally, we can see here when the model was wrong, the false positives and the false negatives. It flagged 18 normal transactions thinking that they were fraudulent. These are the false positives. And it flagged it failed to flag 27 fraudulent transactions that the model thought were normal, but they were actually fraudulent. So these are the ones where the model was wrong. And we can see accuracy 85%, precision 88%, and recall 83%. And the confusion matrix is just like putting all of these four into a little matrix, which a data scientist would prepare for a slide, a much prettier version. But that's it. This model has been successfully evaluated. And what can we discern from this? Well, at the moment, I would say recall is lower than precision. That means that 27 real fraudulent transactions, the model failed to detect them as fraudulent, while there were 18 which the model flagged as fraudulent, but it just bothered some customer who had to use a different credit card. This, I don't really care about that much, but 27 false positives, false negatives, means that we failed to protect these 27 customers. So I am not happy with this recall score of 83%. I would like to train a different model to see if it can get a better recall score, even if the precision becomes lower. Also, I mentioned that we used the default out-of-the-box version of this model. There are parameters of this model that I can tune so that I can make it more biased towards saying that it is a positive, so that I can reduce my false negatives. And after making this model evaluation, as a data scientist, I would go back to my models and see what other models I can train and find the one that has the best score of what I am looking to optimize. In this case, for fraud transactions, recall. If I were to have 3 models that all have really good recall scores, maybe then I would say like, okay, I reached the 95% recall, so let me look at how well they do on the other ones. And then as a secondary metric, I would say out of the 3 that tied for recall, I'll pick the one that is best for precision, for example, so we don't have to bother as many customers. But this is what the performance evaluation looks like for classification. This could be for fraudulent transactions, as it could be for detecting a tumor on a X-ray scan, as it could be for detecting a spam email, or it could be for telling whether tomorrow it will be a rainy day or not. For example, all classification models can be evaluated in the same manner, following the same principles, which is why data scientists can be useful no matter the business domain, because these tools are generally applicable. The only thing that needs to be there is data that contains useful information to make predictions on some future outcome. And yeah, that's all about classification. Regression is very similar, but it uses different metrics. In any case, let me go back to the presentation and show you that evaluating for regression, we will be sharing this presentation, but it's similar, just not in the sense that you're evaluating classifications. You're evaluating how good the scores are. So if you're measuring sales for the next month, you're not going to be like in classification, completely off or completely in the money. You're going to be able to measure how far away you are. So if the sales are 10,000 and you measure 10,500, you can measure what percentage of you are. Thank you for your time, and we'll be continuing in the next one, where we'll be finishing with looking at regression evaluations, and then also looking at different kinds of models that we can use and when they work better, pretty much. So that one will be more for people who want to start using the models themselves.